First of all, I'd like to thank Rod and the Best Practices magazine for allowing me to come in and speak to the crowd. It's humbling to follow the three speakers that come from such accomplished backgrounds. Hopefully, what I have to say will add a little additional information or knowledge to the mix that you can take back with you to your facilities or back to your jobs. The three speakers that have spoken prior to me have really talked about things on a very high level, and what I'm going to do is kind of bring things more down to a plant level. Once you take this inspiration and knowledge that you've gotten from these breakout sessions and from these speakers, this will allow you some things to think about as you want to implement or begin the process of going down the road of integration or controls or automation of your compressed air system. First thing that needs to be considered when you're looking at your compressed air system, do you really need an automation package or an integration package? Should I buy? Will it really benefit me? And that's something that definitely needs to be investigated at a plant level with your in-house engineering team, as well as you can bring in outside auditors or vendors that can assist with that process. Second thing is, okay, you've identified the need for some integration or automation for your system. Then you have to figure out, where do I want to go for this product, or what's the next step forward in terms of finding sourcing the correct solution for my plant. And then the third thing, once you figure out where you want to go, then exactly what product will really best serve my particular compressed air system or my facility. And in my opinion, based on my 25 years of experience in the industry, those are three very key questions that need to be addressed early on in the process when you're making an evaluation of your compressed air system for controls upgrades. It's really easy to decide, should you buy? Typically, it's a matter of having an air audit or an air study or an air assessment performed at your facility. And also you need to factor in what rebates or tax credits that might be associated with this type of program. Once you've done that, then you can identify what the investment would be, what the payback would be, and typically if you have any air system of any size at all, there can be appreciable ROI for the project. So that's definitely the main two things I would recommend that you consider. Then another thing is the risk. One of the things that people think about when they're installing or thinking about installing a control system is, what are my risks here? Well, what happens if I don't have compressed air when I need compressed air? And most often than not, you'll have enough energy savings to offset any down production. And if you implement it properly and do all the proper testing up front and make sure the system's working as well as it should, then that should not be a problem. But if you're in a facility or have a process that 30 seconds of downtime would offset 2 years of energy savings, I would suggest maybe you think about go ahead and keeping that compressor running that doesn't need to be running because the risk of trying to save a few $1,000s in energy may be offset if by any chance at all that your control system is not able to bring a compressor on as quickly or at all when you need the air. And of course, there's other benefits with control systems. You get the benefit of remote monitoring, you get the historical trending, and you can do maintenance tracking on your machines to make sure that machines are done maintenance on the proper schedule. And then Of course, one of the big things, the hot topics in the market now is talking about artificial intelligence. I mean, the centrifugal compressors have artificial intelligence built into their controls for many, many years. They basically, you look at various parameters and operating conditions and see how they affect each other and then make a decision. Well, where I'd like to see this go is take it another step, where you look at the whole system and how is the compressor affecting the dryer? Is there some changes in the system you could make that would benefit the overall efficiency of your system? For instance, if you have centrifugal compressors and you're in a blow-off state, well, what if you slow down your water flow to the compressor, where you're not making as much air, and you take some load off of your cooling tower or chiller, and you're making less air, and then all these things work together. So it's very predictive and very intuitive, but I think that's the next step we're going to see, is where we have the same type of multiple algorithms and considerations looking at a complete compressor room to make smart decisions to optimize the compressed air production. I have a little problem with the clicker. Oh, there it goes. This is something many times a plant will have very, very old compressors, and they'll be like, well, I think we can really improve our efficiency if we put in a control system or a sequencing package. And you come in, you look at the air compressors, and you're like, I can't believe these things even run, much less you expect a PLC or a computer to start these compressors. And at some point, you need to take a step back and say, well, I think I could spend that $50,000, $100,000 maybe investing in a new compressor. That might be the better solution for you. So that's something that's really the first question that comes out of my mouth when I see a customer and they're asking about automation. And I'll ask, how do you start your compressor? And they're like, what do you mean? I was like, if you hit the button once, will it start? And usually it's the case of, yeah, it will, and not always. And if that's not the case, then that's not a candidate to be put on an automation system. Another thing I like to challenge engineers and plants to think about is, you've got a fixed set of assets, horsepower compressors. A lot of times, oh yeah, we put in our control system, we'll save you 40% of energy. Oh yeah, easy. And then I like to take a step back and say, okay, we're not adding any new compressors, we're not taking away any compressors. Explain to me in detail how you're going to make my 4 compressors save this amount of money. And if that integrator or systems control engineer cannot explain to you how their solution is going to make those 4 motors run less or consume less energy, then you might want to double check their numbers or look at another additional resource to evaluate your system, because they're probably just reading off of a brochure and spouting out percentages that they can't back up or justify, because every compressed air system is different, every plant is different, and you can't just paint a broad brush of energy savings without taking a deeper dive into your assets that are online. And also, one thing that we're seeing more and more from the systems that I've looked at over the recent history is that demand charges. I mean, we've always been told that we want to turn off every compressor we can turn off and only turn one on when you need it. Well, sometimes we're finding that certain times of the day, you're better off to maybe leave one of those compressors running unloaded and allow it to load up as needed, because that little window of time that you start that compressor will bump you into another bracket in your energy bill. So those kind of things add complexities to the system, but they must be considered, because that you do not want to take a step backwards when you put in a control system. You want to make sure it can meet your needs, and the needs are becoming more and more complex as our energy bills become more and more complex for how they're breaking down our bills and what we're getting charged for. Another thing to consider when you're installing a control system is control gap. I mean, it's been very, very prevalent over the last 10, 15 years to consider a variable speed compressor as the solution to your compressed air system pressure and energy problems. But you just have to be smart about it, especially if you're putting in multiple variable speed compressors or multiple centrifugal compressors. Turn down of a variable speed obviously is far greater than what your turn down on a centrifugal compressor is. So depending on the number of compressors and how your air usage varies over the course of a week or over the course of the day, that needs to be taken into consideration, because it's very common to have a system that works beautifully for first shift, and then when you get into the second and third shift, it's just completely out of control, because that's not where the focus of the design was. It was designed to handle the peak conditions, but doesn't handle the off-load conditions quite so well. So those are things that need to be looked at very closely when you're considering putting in a system. And one thing that's always been a pet peeve of mine is you've got 4 or 5 modulating compressors that have been modulating forever. And I mean, they're running partly loaded, and all of a sudden you put in a control system, you're like, okay, I'm going to turn off 2 of these compressors because I'm going to make those 3 run fully loaded. And it works for a couple hours until they trip out on high amps, high temperature, or something, because they haven't been maintained in a manner that will allow them to run fully loaded. So that's one thing I always ask plant personnel is, this machine that, it's modulating and it's consuming more energy than it should, but can it run full loaded? And can we see it run fully loaded before we implement a control system and try to ask it to do something it's not capable of doing? So that's something that is a very important when you're trying to control inlet modulation compressors. And this is what I was talking about a few minutes ago. If your compressor can't start with the push of the button, then you're going to have to find it, either not put it on the system or replace it with a newer compressor. This is a true story at a facility where it was an old recip they were wanting to tie into the control system, and the question was, okay, what do we do to start this? Because it was older, and they said, well, this is what we do. We pump the oiler twice, then we bleed down the air lines of the control air lines, and then you have to push against the starter cabinet and jiggle the disconnect, and then you hit the start button and it comes right up. And I'm like, okay, how do you expect us to automate that? And that can't be done. So we said, we'll just leave that one off the system, and you can, if the plant crashes on low air pressure, somebody can go turn that compressor on, because we don't build robots. We just make integration packages and automation packages. And then the third question is where to buy. This is always something I find very interesting in having conversations with plant personnel is, if you have a local distributor who's supporting your plant, many of them will say, yeah, we can sell you an automation package, or yeah, we've got sequencers. And but sometimes they've never sold one or they never installed one. So I would ask questions and definitely ask for references of similar situations or similar installations where they put in this product. Then the other option is you can go out to a third party that's, say in California, and you're in Tennessee, and they have have hundreds of systems in the field that are all running great, but if they haven't been to your system, really haven't had much interaction with your particular compressed air system, they may not be able to fully automate, especially if older compressors that require a little special care and getting them running, they may not understand those caveats with your particular plant. And then how quickly can somebody across the country respond? I know nowadays the remote monitoring and being able to dial in and remote in to systems, it makes it a little easier to troubleshoot remotely. But from my experience, when compressors are on a control system and there's an issue with performance, more than likely it's the compressor not responding properly to the command, whether it's somebody that has flipped a switch, taken it out of a remote control, or if it's a high temp alarm that's tripped out and somehow another got reset, but yet the sequencer is not aware of it. I mean, there's so many things that happen at that level. So in my opinion, the best answer is the best of both worlds. Have local support, whether it's in-house or your distributor who supports your equipment. And it could be local. Some distributors have their own systems and been doing it for years and years. There are other independent companies that do it quite well. And I think having both parties work together is the best solution to get the best product for you or best solution for your plant and be able to maintain that over the course of time, because I mean, it's probably 10 to 1 in my experience that for every 10 issues, one of those is because this controller has got some glitch in it that it's not responding to your particular plant, and the other are related to how it's communicating or integrating with the air compressors. And if you just go online and start Googling and just buy something off of eBay, Craigslist, Amazon, good luck. That's just not going to work. And got just a real quick overview of what I consider really the 3 types of level of controls and integration for your system. You've got OEM controls. If you have all light compressors, you could daisy chain those compressors to go together, and they'll respond to the pressures effectively. And you can't do a lot of customized programming, but if you have if you're not asking your system to do a whole lot and you want to do some very basic rotating and turning on and off based on demand, they typically do a fine job. And a master sequencer is the great thing about a master sequencer is it's not brand specific. It can take control of all different brands. It can communicate with those several different ways, whether it be dry contacts, Modbus, or other communication protocols. And then what I call a full integration package is one that actually has to talk to your compressor. And it has to be a compressor that has an open protocol that will allow it to speak to the system, but that will allow you to read all the data, especially when it comes to centrifugal compressors, where you get your vibrations, your amp draws, temperatures, and everything that is so critical to those machines. You can trend those over time, and it's also those are typically more expensive investments, so it affords you more leeway in terms of purchasing equipment to support that. Excuse me. This is just a curve. A lot of people. This is kind of going to remedial air compressor or air compressor 101. A lot of people aren't in the compressor business, but they're in energy, and they talk about compressor, steam, lighting. So, and you see these curves, and so 20-year compressor guys, they can tell you what each one of those curves are, or lady. And but for the typical engineer or typical layperson, they're just curves. So what I've done is I kind of real quickly will show a comparison of compressors to lighting. And so lumens, how bright the light is, would equate to the flow or CFM of a compressor. And of course, watts of the light bulb would be a power relationship. So very simplest of all controls, lights. Light switch on, light switch off, on, off. That's the simplest of all compressor controls. So if you hear on, off, or load, no load, It's either making light or it's not making light, making air or not making air. It's very basic. Inlet modulation is something that, the reason I put shades on that is because when a compressor modulates on its inlet valve, yeah, it's stabilizing pressure, but it's saving very, very little energy when it's doing that. So I call it shades because, yeah, you're holding pressure tight, but you're not saving any energy, so it's kind of just keeping your eyes can adjust to the light, but it's not really doing anything to reduce how much light's being produced. So it's not really regarded as a high efficient means of controlling compressors. And then of course a variable speed drive compressor, that's pretty obvious that you change the speed of the motor, it changes proportionally to how much air is produced from the compressor. It's no different than a dimmer switch on a light. You turn your dimmer down, the light dims down, you turn it back up, and your how much light you see is proportional directly to what position you have that switch in. And the same thing with an air compressor. It just slows down the motor, speeds up the motor to meet your plant pressure demands. And one that doesn't get talked about a lot, primarily because two of the largest producers of air compressors in the world don't necessarily offer this particular type of control on air compressors, but there's another control called variable displacement that a lot of people don't fully understand. And what I equate variable displacement to is very similar, in my opinion, to the adjustment of the inlet guide beams on a centrifugal compressor. It's very linear in how far it can turn down, and it controls pressure in a manner that's also energy efficient. So they go by spiral valve, turn valve, poppet valve, a lot of different types of variable displacement products. But it really is, if you equate that to a lighting system, it's basically, if you need X amount of light and a 36-inch light bulb is going to give you what you need, then that's like a fully loaded compressor. So you only need 75% of that air, so what you do is you take a hatchet and you cut off 25% of your light and set it in there, and that's how much energy you're consuming. Same, you just make it smaller. So when they say variable displacement, it basically is just changing the size of the air end or the pump of a compressor, and it's just by doing that, it limits how much air it can produce and in effect how much power it takes to produce that air. So that's kind of taking a step back to give an idea of what I consider a comparison of different control technologies. And another thing we talked about real quickly, IoT and Internet of Things, Industry 4.0, and this is kind of my idea of artificial intelligence is a machine. For instance, you have a compressor. Obviously, artificial intelligence is taking over this slide. So the bottom line was, I envisioned these machines talking to each other, and they actually develop personalities. And the building management system will have its favorites and pick on various components throughout the building, and then they'll tweet against each other. And it'll be fun to watch industrial products having these political type wars. But there it goes. I didn't touch a button, and it came back. So. Yeah, that's the system talking to the compressor, and the compressor is blaming the dryer. So, and the dryer says, "Oh, it's fake news." So that's where I see the artificial intelligence heading, and that wraps up what I had to share with you today. So, thank you for your time, and